So we have here Alessandro Palmas. He is an aerospace engineer with a great passion for artificial intelligence and machine learning. And he has over 9 years of experience in software development for scientific applications. He is a co-founder of various innovative initiatives around cloud-based simulation platforms. And he will present today Diambra is one of them. He works on reinforcement learning, of course, especially applications for video games. And he's also the co-author of a book, which is called the Reinforcement Learning Workshop. Yeah, so I think then we are ready to get started. So maybe general information. So we'll have first some slides from Alessandro about this topic, video games, for video games. And then we will go into a little bit into the discussion of the AI tournament that maybe you are looking forward to. And hopefully there we can already answer most of the questions. However, if you have questions, that's also very much here the event for you to ask questions. You can do it under the F&A tab. Yeah, so maybe definitely at the end we will go through the questions there. And with this, I think you can start, Alessandro.
Perfect, perfect. So thank you very much, Klaus. And let me thank you all from RLZ for this great opportunity. I'm really happy to be here, and in particular for the organization of our AI tournament that we just launched. Everything started last Tuesday, and it will last. We will talk about it. It will last more than 2 months, so a lot of time to get familiar with it and start playing with RL in video games. So I'm gonna share my screen. First of all, let me introduce myself. A few words more with respect to what Klaus already said. I'm from Italy, more precisely from Cagliari in Sardinia. And as Klaus already told you, I'm an aerospace engineer, but both during my college as well as right after it, so during my early days in companies, I started diving into advanced software development, in particular for space flight dynamics, and so orbital flights, and as well as computational fluid dynamics. So two different fields, two different, let me say, type of equations that requires very careful software development to deal with them. And I've been always been passionate about different types of software development. So I've been lucky enough to being able to merge this passion. So in some sense, aerospace and engineering with software development. Then it dates about 5 years ago, I started diving into machine learning in general. And this is because we were facing some goals of how to creating automated workflows in specific contexts dealing with CFD back then. And so I approached the field with a very important curiosity, and I was really intrigued by capabilities in this domain that were starting to emerge. It was around 2014, 2015. And deep learning was basically every day on the news, especially for computer vision. Then, I talked about college, I talked about jobs, but there is another important thing about myself that comes into play in what we are gonna see today, and this is video games. I'm really passionate about them. I really like them. I spent, let me say, a lot of time on them. And when I say a lot of time, I mean a lot in different type of games. But this is a very, very interesting field for me. And but getting back to where this merged with machine learning is in a particular subfield of it. This is a very standard way of grouping, let me say, subfields of machine learning or presenting them. And even when you start the general introductory course on machine learning, you are usually exposed to this classification. So three different subgroups: unsupervised, supervised, and reinforcement learning. And right from the beginning, I've been always fascinated by reinforcement learning. So the idea of having a software that is able to learn things, so how to act optimally in a given environment, was something that really hit me back then. And so it was clear uh, for me that was where I wanted to uh, learn the very important part of machine learning. Of course, when you have to deal with reinforcement learning, and we are going to see that also today, you do have to be familiar with other aspects, like standard classification methods based on deep learning. And this is especially true when you have to when you want to approach complex problems, and so trying to leverage deep reinforcement learning. Okay. Well, at some point during this process, one key thing happened, and this is it. So for those of you who are not familiar with what I'm showing you right now, this is a screenshot taken from a live play moment of OpenAI 5. OpenAI is a company based in San Francisco. I believe most of you know it. And of course, it's not the only one. Great achievements have been also reached by, DeepMind, of course, and other players. But in the world of video games, this moment was very important for me, at least. Because I didn't know Dota 2 at back then, and actually it is not one of my favorite type of games. But I found myself when OpenAI 5 went out, basically staring at the game like for hours, watching the AI playing against the best players in the world. And it was just those kind of special moments in which you find something that strikes you. And here, watching something that seemed to be a human playing, actually five humans, because the AI was controlling five different characters at the same time, um, was really enlightening in some sense. And so it is in that moment I decided to I wanted to do something in this exact intersection, so between RL and video games, um, in particular trying to achieve this kind of inspiration and being able to communicate this kind of feelings. Okay. And so I started diving into, of course, theory about RL, papers, and also maybe this is the most important part, starting to perform experiments in this domain. Of course, you know that reinforcement learning is still, in some sense, one generation um, far from with respect to where supervised learning is right now, meaning that it is something that requires a lot of computational power. So in other words, the sample complexity is very high, meaning that you need to have longer interactions between your agents and the environment. And this, if you want to obtain results in a limited amount of time, you need to use a high computational power, or you need to approach simple problems. And so finding the best intersection of these two things was of course one aspect of this journey. Okay, so yeah, just let me briefly recall here a few important aspects of reinforcement learning that are used will be definitely useful when talking about tournament specifics. um, yeah, the first step when approaching reinforcement learning is of course how you frame your problem. And in order to do that, you have to, the first step is to frame it in the so-called has a so-called Markov decision process. So the we can, you know, try to build it from a very high level perspective on video games. Then it will be more clear later, maybe when we will show you standard interaction with it. So of course we have an AI agent that is going to interact with an environment. Okay, and uh, it will send actions to this environment. And I'm, you know, in these pictures, you will, in some sense, you will see it from the video game perspective, and the way in which we send actions to environments, to our environment in video games, is through, for example, a gamepad. And so you pressing those buttons means you are selecting actions that you believe are perfect for that specific moment in the game. And the environment returns two things in the Markov decision process framework. One is state, or maybe it would be better to use the word observation, because these two things can be the same thing or not, depending on how you retrieve information from the environment. And so, for example, in a very simple video game, um, the state can be the specific frame in that exact moment. And the other element that is needed is the reward. So the reward is a measure of how good you are doing in that environment. And for example, it may be associated with you completing the game, or you collecting coins during your gameplay, these kind of things. Again, this is gonna be even way more clear later, way clear later when we are going to use the our own environment. Okay, and finally, of course, when you play a video game against the computer, let me say, these actions by the computer are embedded into the environment. Okay, this is different with respect to when, for example, you are facing a different opponent. In that case, these actions are, something that is outside with respect to the environment. So yeah, in order to approach our own environment, this is more complete, clear picture of what we are going to see and to receive as state and reward. I will go through it later when we will take a look at the environment running live. Okay, but in general, the state can be composed by, of course, frames, but also additional observations, like, for example, in case of fighting games, your health, the health of your opponent, your previous actions, stage number, and all these type of things. Okay, so the goal of a reinforcement learning algorithm is to find the so-called policy. This is something that basically links your inputs, that is your state or observations, to outputs that are actions. Finding this link so that you are optimizing your goal, and in the specific case of the MDP is your total cumulative reward, is the final, target of our reinforcement learning agent and our training, our agent training. So why this thing has to deal with video games so much? Well, it is video games are a natural environment in which our reinforcement learning can be applied. If the goal here is to let the agent interact with the environment and learn how to behave optimally. And this, when framed in an end-to-end approach, it means that your agent will start taking random actions. So actions chosen completely at random, and then considering rewards received during these interactions, he will learn, your agent will learn to increase probabilities for good for actions that led to good rewards and decrease probabilities for actions associated with bad rewards. This requires a lot of interaction, and of course, especially in the very early stages of training, your agent will behave in a very not optimal way. So these interactions needs to happen in a virtual world, both because you cannot, for example, for autonomous driving, you cannot let a car taking random actions on a street, for example, or your trading agent buy and sell stocks randomly. And so you need the counterpart in simulation in order to allow it to experiment and explore all these type of things while being safe. The other important point is that with simulated environments, with virtual environments, you can perform training in parallel on multiple instances of your environment. And this, of course, is something that speeds up training quite a lot. The nature of video games, where the virtual version and the real world version is the very same, is of course makes them the perfect test bed for research and experimentation in this world. At the same time, or maybe given this specific aspect, reinforcement learning agents are starting to emerge as important applications in the video game industry in many different, specific direction. For example, here we are watching, for example, a specific frame of a single player mode. And of course, for example, non-playing characters, or in general, the history of your single player campaign would benefit a lot by the use of reinforcement learning, because it using these technologies, you would be able to embed intelligent or let me say intelligence inside your single player mode, and providing a better gaming experience. At the same time, also in multiplayer games, it is very interesting because, of course, and this is as for example has been already implemented in a few games. When you are inside, and I believe I do have here, for example, a reference. When you are in those servers that host multiplayer games, and you are with other competitors, for example, in that specific game room, when a lot of them maybe drop out from the room, you may experience a sudden termination of your game, and this is not good for the game industry. Instead, they are looking at a way to replace human opponents with good RL agents in order to let you continue your experience and have a better feeling in this specific regard. Also, reinforcement learning agents can be very useful in terms of games testing and also replicating human behavior for in order to study specific conditions of games in which users usually find themselves. So yeah, uh, this technology is pretty young, and something that has been in, in a very frontier in terms of research, but we are also starting to see um, how these technologies can be applied in the real world in industry. So basically, putting everything in the same place, this is what came out. The Ambra is something that started more or less 3 to 4 months ago. Actually, in the very last part of last year, and you can, think about it as a place where we like to show you how, on one side, how a reinforcement learning works, so you can watch improvements in terms of techniques, as well as getting the feeling of how this algorithm grows in time when you allow more training and all key steps that you need to perform to reach good performances in applying them to specific video games. Everything started, as um, with the common ground of merging these two worlds. We stream things live on Twitch, and you can find on our website everything about it. And but I believe that there are different modes, of course, that are shown there. So of course, the standard one is letting your AI playing against the computer, but of course also um, tournaments between different AIs are also something that, of course, will be presented, as well as at the end with very good AIs, um, letting our agent face a real good human opponents. And this is where we are, you know, uh, organizing our AI tournament together with RLZ. And this is the very first one. As I said, we just launched it last week. And we already have many different participants in it. We are already 30 people that are inside registered in our tournament. Registration is pretty easily done within our website. And yes, the very first one, with the aim of letting you train your agent to play Dead or Alive. That is the first game we are providing as environment. Is a fighting game, and I can, later I will show you a trained agent playing it, and I can assure you it's really something so rewarding when you have, you know when you are watching your trained agent playing. And I can already tell you that my agent plays way better than me already. So this is where we are launching this challenge. And of course, let me just show you very briefly where this is the website. And of course, on the top bar, you can go on AI tournament section, and there you can easily register there. You see here there is a leaderboard. So far, no submission, but I'm almost sure that this week we will have the first submissions. And submissions are collected weekly, so the deadline is every Sunday. And then agents will be evaluated during our live on Tuesday. And so you will be able to watch your performance, no, actually the performance of your agent live on our stream. Best 5 agents will take part in the final event here live on RLZ meetup, and they will fight for the final prize. So just to be totally clear, this is how the total money pool is split by the first 3 places. And we are really looking forward. I know Klaus, Mark, and Georg are really curious to see how this is going to go. Anyway, you find all info here, but we are going to go through them here in our meetup. So I believe this is it for the first part, Klaus.
Yeah, great. Thanks a lot for this fascinating introduction. Yeah, so then I think, as we said, so we want to look in more detail a bit into the tournament, and especially give people the opportunity to ask questions. Just maybe as a reminder, you can find it on the website, but you can already submit your policies, your agents. And then there's a weekly submission deadline every Sunday at midnight. And you can then watch live the performance of these agents on Twitch. Maybe Alessandro will show some examples. And if you want to participate, there's an entry deadline, the 25th of May. So then you should start before that. And the submission deadline is final submission 22nd of June. And then we have another the final event where we will look at the best agents on the 29th of June. So that will be definitely interesting. Looking forward to that. And I think we have already mentioned what the price is.
Yeah.
So maybe one thing we can look into, Alessandro. Could you share a bit about the technical details, about observation space? How does it look like? Actions, reward function?
Of course. Let me share again my screen so that I am able to. Okay, so let's start from the observation space. So what the environment returns after every single step is basically, you can think about it as a 3-dimensional observation that is basically, here you see sizes. It's 128 times 128 for 5 different channels. So this is composed by the first 4 channels are basically the last 4 game frames, so time steps of the game, and these are frames of 128 times 128 pixels in grayscale. Okay, so grayscale images. So starting from T0, the very last step, and then going backwards for additional 3 steps. This basically allows you to know both the current game situation as well as previous game situation in order to have access to dynamic information. The 5th channel, it contains the so-called additional observations, meaning that if you reshape it in a very long line with the standard NumPy reshape function, this vector that results in this reshaping will contain, the first number is the number of additional parameters, additional numbers that you will have in this long line. And then starting from the very next value, you will have, first of all, previous actions, in particular 12 previous actions in the one hot encoding framework. So I will talk later about action spaces, but for example, one option is to have 12 actions. In that case, you will have all zeros for all actions, but the one that has been selected, that is going to be equal to 1. This is how one-hot encoding is performed. You will have access to the last 12 actions performed. This is something that is useful if you want to perform combos, because combos are combination sequences of actions sent to the environment, and so having access to a buffer of 12 previous actions allow you to explore this specific thing. Then next 4 values are your own health of your opponent, your side and opponent's side, and this basically is just a 0-1 value that basically tells you if you're on the left or on the right of the screen, not only when the match starts, but in every single instance of your game. Then you have stage, and for Dead or Alive, the entire run is made of 8 stages. So you have first 7 stage, and then there is the final boss. So this number is linked to this specific aspect. And finally, you have again a one hot encoding set of numbers that basically tells you which character you are using. Okay, not the opponent, you are using. And this is it for these additional observations. All values, for example, for health, side, stage, all these values are normalized. I can, the best thing to get familiar with this observation space. And of course, if you have questions, this is the right place to ask them. But the best thing is to get familiar with them using the Python notebook provided. In order to, take part in it, in this tournament, you have to just download the GitHub repository, and there you will find many different notebooks, Python notebooks, that gives you every single needed function to print out these observations and get familiar with them, play with them. We do also have a Discord server. Again, the link, you can find it on our website, and you can join there, the community, the Umbra community, and ask for support. I will answer you directly. And so if you have specific questions, you can also go there. And this is it for the observation space. So 4 frames, let me say 4 images, and 1 matrix with numerical values that can be just reshaped in this way and used directly. For every game tick, you have these observations. Moving to the action spaces. Maybe one thing I should mention here, you can, for example, this is the observation space that you are going to use. You can, if you think it's better for you, you can use avoid using some of them. For example, let's say you want to train your agent only using frames, that's fine. You cannot use anything more than this, but you can definitely discard some of this. And for example, you can train your own policy for a specific character. So there's no need to have a policy that is valid for every single character. So you can select one of them and just train your agent to use that specific character. And so in that case, you don't need character info. So because you would be using always the same one. action spaces. There are 4 different action spaces available, and in this case you can select the one you prefer. These 4 action spaces are created, selecting 2 different aspects. First of all, if you want to define them as discrete action space or a multi-discrete action space. This discrete action space means that you would be treating move on the very same level as attack buttons. So, pressing left would be treated as equally to pressing punch. In that case, they go into the very same set, and that's it. While for multi-discrete action spaces, you have 2 of them here. You are treating, moves and attack in different ways. So you have 2 different sets, and you have to select to pick one action from each set every time. Another option is if you want to use attack buttons combination or not. In Dead or Alive, you have 3 buttons. That is, you have hold button, punch, and kick. They can be used, pressing them alone, or they can be used in combination. So, for example, hold plus punch, hold plus kick, or even all 3 of them pressed together at the same time. So, in the discrete case, you have a total of 12 actions if you select no attack buttons combinations. So the first one would be no action. That is an action indeed. Then you have, of course, left, top, right, and bottom. So 4 plus all 4 intermediate moves plus 3 attack buttons. Okay, so a total of 12. If you use discrete with attack buttons combination, you would have no action, so that is the first one, then 8 moves, then an additional 4 buttons with respect to hold, punch, kick, and then you would have hold plus punch, hold plus kick, punch plus kick, and all 3 together. So that would account for 16 actions. And for multi-discrete, you just have to combine these numbers, obtaining 9 by 4 and 9 by 8 actions, possible actions. These are trade-offs. Of course, using attack buttons combinations is an advantage from the point of view of move options, and also for example, when you are under a catch from an opponent, in order to stop that sequence of catches, you need to press all 3 buttons together. So if you don't allow your agent to have available those attack buttons combination, you are playing with an handicap in that specific regard, so you won't be able to exit a sequence of catches. At the same time, the bigger or the larger the action space, the longer training will need to bring your agent to a good nice performance. Just to give you, okay, let's move to the reward function. It's pretty straightforward. The one that is the default one, you can tweak it if you want. You have access to the Python code for the gym environment, and so you can tweak it if you want, but the evaluation will be performed with the default one. The default reward function is very simple. It's every time you hit your opponent, you receive a positive reward proportional to the value of damage you inflicted. When you are hit by the opponent, you receive a negative reward equal to the damage the opponent caused you, and that's it. the normalization of this one, of this specific reward, is so that every full health bar is equal to 2, meaning that if you complete a stage, that is, you need to win 2 different rounds in order to complete a stage. If you complete a stage with 2 perfects, your total cumulative reward would be equal to 4, okay, because it is equal to 2 health bars. Now, okay, this is for later. So this is more or less the description of the action space and observation space and reward function. Let me just, here, if you go on a website and you have access to our GitHub repository, and there you will find both notebooks, as you can see here, as well as the source code for the gym environment that is right here. So if you want to tweak the reward function, for example, taking into account also for time, you can just modify the source code here. But remember, evaluation will be performed with the default values.
Alessandro, since I see some people already ask questions, they go into the direction. Maybe we can even look at the code.
Yes. The very simple. Interact with the code is very simple, and this is the gist. It's contained on the README, and you also have it available. Let me open it. It's right here. So it's very, less than 40 lines. You import the gym environment. It follows the OpenAI gym standards. So as you can see, you import it, and then you perform a set of, a setup here. I will go through it in detail in a minute. Then you just initialize your environment, calling the constructor here. Then you call the first reset that returns an observation. And then you start your for loop. Here it just performs 100 steps, and you select your actions. Here you see there is a random sampling from the action space. You select your actions. Here is where you put your RL agent. So using the observation, you select your actions, and then you send your actions to the environment. As you can see, I'm not sure. Let me just go. Okay, increase the font size. So yeah, here you select your actions, and here you send them to the environment with the step method. If when you complete your episode, either because you lost 2 rounds against one opponent or you completed the game, then you just call reset, and that's it. This is how to interact with the environment. And this one, row 32, is where you need to place your, let me say, your RL intelligence in some sense. So these are settings that are related to the environment. For example, of course, there are some simple settings related to where you extracted this repository. You have to set them appropriately. And then here, for example, you have flags to activate or deactivate rendering of the game, to lock FPS. These games run at 60 FPS, but if you want to go and speed up training, you have to turn off rendering and FPS lock so that you can reach about twice the speed, more or less in the range of 120 FPS. And then you just have these 3 settings, like difficulty level, characters to be selected, and outfits. So in order to make things even easier, this is the basic interaction with the environment. Okay, and you find it. There is the Umbra gym gist.py in the repository, but there is a dedicated folder that is called AI Tournament. This one can be reached also directly from our AI Tournament page if you go here, there is a dedicated section of the Umbrel repository, and this is AI tournament. Inside it, you find Python notebook and a submission example. The Python notebook, if you open it, let's see if GitHub, okay, it is able to open it. So basically there are standard imports, and then there are environment settings, and these are those fixed settings you don't need to modify, you don't have to. And then here, custom setting that we were mentioning. So rendering, lock FPS, of course, sound if you want to use it with sound, and then your cutters. We have also here selection of the action space, those options that I was mentioning, discrete or multi-discrete, attack buttons combination false or true, and that's it. There is only this additional one that I can, of course, describe just a second, and then, with all these settings, you are good to create your environment and start the loop that we already took a look at. That's it. So the last aspect is this one. This specific setting, continue game, is something that you may use if you want to let your agent hit continue button when losing against one opponent. If you use 0, basically your episode ends the first time you lost 2 rounds. You have 2 options. If you use a value that is between 0 and 1, so a real value, your agent will continue a given percentage of times. For example, if you use 0.5, 50% of the times it lost, it will press continue, allowing it to face the same opponent over and over. Another option is to use a negative value like -2. In that case, your episode will end after 2 continues pressed by your agent. So you can use this one. And for example, in one specific game, I needed to change this value in order to let my agent play longer with opponents in the later stages. And but be aware that this will be 0 during evaluation stage. Okay, so we will evaluate agents using this value set equal to 0. And this is how you interact with it. You can just refer to this specific Python notebook you find inside the AI tournament folder, and that's it. Everything you need to know is in there. So maybe, Klaus, it's useful to right now talk about the submission example.
Yeah, I think
Do you
so.
agree?
Would be good. Please look at it.
Yeah, it's a folder inside the AI tournament folder, and it's composed by 4 different things. Let me say that the most important one is the agent.py. All the others are optional depending on your choices. Of course, you have to let us know what's the packages, the OS packages you need, and your Python requirements, and that's where you have to put those info inside these 2 txt. Then, for example, you may need to upload your model parameters that you saved after training. And that's the other element. But the key point is, of course, our agent. You just need to implement this class, actually to customize this class. What you find inside the repository is a random agent. You can just modify it, and what the key method is the act method. This method receives the observation as we described it, and needs to return actions. So this is the method that I will call in our evaluation scripts. It receives observations. in input and provides actions in output. That's it. As you can see here, you can modify the observation as you wish, but the interface you need to provide is the one with that we just described before. Okay, so an initialization method, if you want, what is needed for your specific model, and then the act method. That's it. So this is what basically constitutes a valid submission. You can, in order to submit your agent, you can just upload that in a standard service, like, for example, WeTransfer your archive there, and then hit new submission here. A form will open, and you can just identify yourself with your user ID and insert here the link of your trained agent. That's it.
Okay, I think that's good. We have to look a little bit at the time.
Yeah,
maybe there's definitely, we want to go through the questions that I see here.
Of course.
But just maybe we can take a little break, and I think you have some video to show example how it looks.
Okay. Actually, okay. Let me share my screen. Actually, it is not a video. We can run the agent live. My GPU should be okay with it. Let me see. Are you able to see my screen? Yes, you should.
Yeah, it's good.
I'm just running. This is a trained agent. I trained it with reinforcement learning library. If you take a look at the website, you can find in the download section here, down here, a set of tutorials guiding you in many different things about how to interact with the environment, how to interface it with stable baselines. That is the URL library that I've been using. And yeah, this one I'm going to show you. I'm not sure we are going to have the time to watch it entirely, but this is, let me just run it. This agent performed about 25 million training steps, and this is more or less equal to 2 weeks 24/7 training. And with this reduced observation space with respect to where this environment was conceived, it allows for very good performances to be reached just after 2 weeks of training. And this is great because our previous version needed 3 weeks. 6 weeks. 6 weeks, and that is kind of a lot of time in order to perform your tests. So let me just, this is where everything starts, and the environment is starting up, and basically is selecting Kazumi. Kazumi is the character that I used for training. And let's see, because this is a version that could be not the best one, but it's good enough to play against the opponent. Let me see. Okay, it's starting. In the bottom left part, you see actions selected by the agent in real time. And as you can see, it is pretty good. It learned combos and stuff. And I can tell you that the random agent is more or less, it's able to perform total cumulative reward of around 0 to 1, more or less. It is able to hit the opponent a couple of times, actually many times maybe, but total cumulative reward is not only based on how many times you hit your opponent, it also depends on how many times you are hit by the opponent. And so if you try a random agent, of course, you would see that is able to fight in the sense that it's able to hit the opponent, but is not super good at defending in some sense. While here you see our total cumulative reward is already at 4.73, and we are just at stage 2. So 2 of 8. Now this is gonna hopefully go for a while. So Klaus, if you want, we can start maybe addressing few questions while the game goes.
Yeah, it's a good idea.
Let me just put the volume of the game. Okay.
I think we can anyway not I cannot hear the game.
Yeah, but I cannot hear you otherwise.
Yeah. Okay. Okay, so some people were asking for frameworks, development frameworks.
Yeah. Okay, interesting. Now, the gym is, of course, coded in Python, and you do have access to it, so you can definitely customize it if you need for your training. Wrappers around it, there are some important gym wrappers that performs normalization and all this stuff. Everything is explained on those videos, and again, you can definitely reach me on Discord for specific questions. Again, they are coded on Python, so everything you need to train your agent is in Python. The library is interfaced with the game in C++, but that's not something that you should worry about. You need Ubuntu or Mint, so Debian-based systems, either 18 or 20. There are different libraries for it. So if you are on 18, you have to use one, and 20 the other one. But everything is specified in the README. Then I've been using, as I said, I've been using stable baselines as a reinforcement learning library. Okay, we lost the first round here. So I've been using stable baseline. That is something I'm using, but you can of course use other options, and also stable baselines. The version I've been using is based on the TensorFlow, but if you are more familiar with PyTorch, that is definitely something okay that you can leverage. So nothing else is needed. Actually, the set of requirements that you find in the GitHub is pretty long, but is mainly because if you want to use the training that I provide in those notebooks with stable baselines, you need to install it. And this triggers, for example, installation of TensorFlow, also TensorBoard, and other things. But for the basic core usage of the gym environment, you don't need so much.
Okay, so then there's two questions on the action space.
Yeah.
About legal actions, is there any limit?
No, you can use, the actions for these games are those that I presented, and you can use whatever you want. The only constraint is to adhere to, either use, one of those for different options, not mix of them and nothing else. But as long as you use those, you are good to go.
And then there's a question about the multi-discrete action space. Does it work with tuples, or is it somehow combined into a single value?
No, well, the multi-discrete is basically composed by two different sets, and you have in every single game step, you have to choose one action from each of these two sets. But apart from that, nothing specific. I'm not sure, I got the question right. Let me know if the answer was enough, or if there is something specific about it.
Yeah, maybe you can write under your question if that was answered. Then some people asking for simple examples to get started, or if you think that this is, let's say, simple enough, or you have another recommendation for people.
Okay, well, the Python notebooks that you find in the repository, they can be, if you install all requirements, they can be run right away. And there is also one that is called the Umbra AI agent that if you have everything installed, in particular stable baseline, it starts training right away. So you have a reference implementation that you can definitely customize pretty easily. So I will, we are at stage 6 of 8. Let's see if this goes on for a long time. Otherwise, I can definitely, you find it on the website. You can find it on saved videos. But there is an example of a policy network, a deep policy network composed by a convolutional neural network plus a fully connected for the extraction of features and concatenation of them for before applying the last fully connected part. And this is something that I provide in the repository too. And so there is definitely a very huge set of elements that allows you to train your own agent. Now, this is this just to let you know, this is the semi-final stage, and as you can see, it's pretty hard because for Kazumi, the semi-final is a Yane and it's pretty strong. Usually, the final stage is easier with respect to the semi-final. Let's see if you're able to reach it. I'm not sure. Losing the first round is something not promising at all, but let's see.
Okay, there's another question about special moves, maybe that correspond to sequences of actions.
Yeah, okay. If you're able to formalize them, you're, for example, if you believe that performing a specific combo continuously would lead you to a good reward, you can do it inside your agent class. But you have to use the action space as prescribed. You can definitely, prescribe a sequence of actions to be performed by your agent continuously, and that's an option. It's totally okay. For now, we never thought about limiting to deeper RL techniques. Of course, we are good and, they are cool for us. But if you find a rule-based policy, yeah, you are more than welcome to submit it. And I'm really curious to see it. So we are at the final stage in the meantime with this agent that has been trained, as I said, just for 2 weeks. Okay, this is lost. Okay, but let's see. Any other question?
Yeah, so there's one question. I don't know if you have tested it on Windows or
okay.
So
yeah, no. We currently support only Linux implementations, and as I said, only the Debian distributions like Ubuntu or Mint 18 or 20. We have plans to distribute the environment at least on also Windows and Mac, but it will take a while. We are planning to do it via Docker, but at the moment this is not available. So.
And then there's an interesting question about human data.
Yeah.
Can we interact directly with the environment somehow?
Very, very nice question. Unfortunately, we only have 1 hour, but okay, let me see. We are able to finish the game in live. Yes. Okay, we completed the game. This agent, as you can see, the total score is about 13.78. And this is is an end-to-end training with our RL. Stable baselines, and after 2 weeks you are able to complete the game. The score is not super high. A very good score should be around 20, but still is very good if compared with the standard random agent. So let me just switch from this to our repository. In our repository you will find additional notebooks like the Ambra Gym recording test. This notebook allows you to record your experience using your gamepad. And this notebook here, the Ambra imitation learning test, this allows you to use that recorded experience to speed up training, to bootstrap your agent, leveraging your own expertise. So you all have, this is of course imitation learning. In some sense you can implement it as behavioral cloning or in an additional different fashion, but you have elements for recording things. You provide with your actions, you provide with your gamepad, and use them to start with your own agent trained with your actions. Let me just stop everything here. We completed the game, and so I can stop everything. Yeah, not sure if there
We have another
are
question.
other. Yeah.
Do you use any kind of pre-training, or could you imagine?
Nice question too. No pre-training. Okay, let me show you again. I'm sorry, I'm interrupting screen sharing and restarting it. This is the network that I've been using. Big blocks. This is it. So frames. So for those 4 frames, they are go inside a convolutional neural network trained from scratch, and additional info there are act as inputs for a fully connected. Then we concatenate them and go into another fully connected. So more or less, this is the architecture. So as you can see, everything is trained end to end from scratch. Okay. I'm using actions probabilities, as you can see, are 12. So I'm using the discrete no attack buttons combination. This is, of course, not the best choice in terms of for having a complete action set, because I'm not using attack buttons combination. And this is something that you really fear when you are against characters like Byman, that is someone that is performs a lot of times continuous catches, and you cannot escape them. And so that's a problem, for example. But I needed just the smallest amount of actions possible to speed up training.
Okay, and then there's a question about a recommendation for exploration strategy.
Yeah, nice. So as you can see here, I used PPO. That is one of the policy gradient, one of the most important, if not the best one at the moment, algorithm that we have. By the way, is the same algorithm that OpenAI used for Dota 2, of course, with different dimensionalities. So you can perform different tricks to foster exploration. One option is to use that continue button. You can perform self-play. You can try to implement self-play if you want. That's another possible road. We are trying to do it in live. Actually, I'm not sure if today, but this week I'm gonna continue implementation of self-play, because that's another option, of course. So letting your model play against himself, playing on both sides. So player 1 and player 2, that's another option. But apart from that, standard things. One thing that I used also to foster exploration is let me say more clearly that it's not mainly focused on exploration, but in order to give you diverse inputs, for example, is using different outfits of the character. So because in this way the agent needs to identify himself in different combination of colors, or just here light intensity, since we are using gray scales.
Yeah, so then there's an interesting question here, because people are worried about the training time. If it's let's say allowed to use the stable baseline trained model that you have shown us, and start from there to optimize.
Well, so far I never released the agent, but let me mention one thing. So I trained this stuff in my own workstation that is pretty low level. In fact, it has an i5 CPU and a very simple NVIDIA 1050 with 4 gigabytes of RAM. So I do believe that, and 2 weeks were enough for what you just saw. So that agent you saw completing the game, and I can, assure you that it's not so easy to complete this game. Still, just needed a couple of weeks of training. But I believe that something that we can evaluate this as the competition goes on, because I feel that it is not so complex to obtain good performances in a reasonable amount of time.
Mhm. Okay, I think some questions already answered by other participants, and maybe also some other questions you have answered them in the meanwhile.
Okay.
Is there any way to train faster than 120 frames per second?
It depends on the CPU, but the bottleneck, unfortunately, is on the game engine. Unfortunately, I try to optimize everything, and that's it. More or less, the bottleneck is there. Even moving to C++ or minimizing, operations and computation on my side. That's the point. But another important aspect, and you can deal with it right away, is use parallel environments. This is important, and this is of course something related with the exploration. Let me show you the this is the AI tournament folder with the AI tournament setup. Here, where you specify, where you initialize your environment, you can specify the number of environments you want to use, and you can do it. Let me see, for example, here, this is the Umbra AI agent, is where you can just run this one, and training of stable baselines will start right away. So you see here, I'm specifying 8 different environments, has a specific input of this one. And this is important, and this allows you to speed up everything. And also, it's a key point in order to let your agent, learn. Because if you use, I tested this, if you use just, 1 or 2 environments, well, this algorithm should not converge. You won't be learning anything. And so this is another important aspect.
Okay, great. I think we have to stop here. We are a bit over time.
Okay,
And
perfect.
I hope we could answer most of the questions.
Sure.
But remember, there's also the Discord channel. So you can find the link on the main website.
On the website, yes.
Yeah, so then you can continue maybe the discussion there. Also, as it's already here, maybe discussing between other participants is also useful. Yeah, and with this, thanks a lot, Alessandro. It was really a pleasure.
Thank you, Klaus.
Also, as always, big thanks to our main sponsor, Swiss Free Institute, for making this possible. And so that's it. So we're looking forward to see how the agents are performing. And then we will probably see something from the channel, some demos there, and we will have the final event on 29th of June.
Yes, it will be definitely so exciting. I'm really looking forward to watching the first agent trained by the community, Klaus. And again, thank you very much to you, to the entire RLZ team. It's really fun and exciting to be here. So thank you again.
Great. And also thanks to all the participants, and thanks for the great questions. So hope you have fun with it. And so that's it for today.
Thanks, you guys. Everyone. Thank you, everyone. See you soon. Bye-bye.
Yeah, see you at the next event. Bye-bye.
Bye-bye.